So this is going on page 107. So the word trigonometry comes from the Greek words trigon, which means triangle, and metron, sometimes said metria, which means measure. So trigonometry literally means triangle measure. All you've done up until this point is right triangle trigonometry. There is more applications to it besides right triangles, but that's all we've done so far, or that's all you've done so far, and all that we're going to do right now. We're getting into the rest of it a little bit later. Okay, so in order, what you end up with is what is called a trigonometric ratio. So a trigonometric ratio is a ratio of two sides of a right triangle. Right triangle. So the trig ratios still are based off the right triangles even when we apply it to things that are not right triangles. Mathematically, when you see the word ratio, what should you think? Because a ratio can mean a few different things, but fraction. Okay, it's a comparison of two things, but mathematically it is a fraction. So ratio tells you fraction. For right triangle trigonometry, here's my right triangle, right? One thing that you need to make sure that you understand is, one of the things early on in geometry that you talk about is the capital letters represent points, lowercase letters represent numbers or values, they're variables. So this capital A represents the point, which we can call this angle A, and then opposite angle A is a lowercase a, which represents a side length. So if this is capital A, this is lowercase a. This is capital C, this is lowercase c. C doesn't always have to be the hypotenuse. It is in the Pythagorean Theorem, that's how you look at it, but really these could be labeled any kind of points at all. Right. So we're going to, when you do right triangle trig to get your ratios, you have to choose an angle, okay, even though we know now that you can find sine, cosine, tangent of 90, okay, they don't all actually have values, but you can find them. We still don't ever use the right angle when we're talking right triangle trig. So we use one of the two acute angles, and it's based on whatever you're doing in the problem. In this, since it's kind of generic, I'm just going to use B just because I'm telling you which one to use, and I don't ever use A to do this part because I don't want you to think it's always the bottom. So you label your triangle, right? What would I label this side? When we're doing this? Is this opposite, adjacent, or hypotenuse? Opposite, right? Then the hypotenuse is always across from the right angle. That's how you identify it. Is it always the longest side? Yes. Do you know the side lengths here? No. So you don't know it's the longest side yet. The reason it's the longest side is because it's across from the biggest angle, and that's how you identify the hypotenuse. So this is the hypotenuse, and then this is the adjacent side, right? Our acronym to help us with trig ratios is what? SOHCAHTOA, S-O-H-C-A-H-T-O-A. So that means we know that the sine of theta, or B in this case, but I can put a theta here so we can call it theta, is opposite over hypotenuse. Right. Cosine is what? Adjacent over hypotenuse. And tangent is opposite over adjacent. And that's what this means, right? Sine, and that's the actual word there, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. Everybody good with that? We all remember that? Which means you also know secant, cosecant, and cotangent, right? So secant theta would be what over what? Hypotenuse over adjacent. Secant would be hypotenuse over adjacent. Cosecant would be hypotenuse over opposite. Cotangent is adjacent over opposite. Okay? Which is basically what we've been doing on the circle. We've just been looking at them as x and y and r. All right, so let's say that we can use this to find angles and we can use it to find side lengths. So if we know the sine, cosine, or tangent ratio, so we know the fraction, which could be a decimal, could be a whole number, of an acute angle measure, you can use the inverse trigonometric functions to find the angle measure. Okay, so remember, does this right here represent multiplication? No. It's like saying if I had the square root of x, it's like the square root times x. That makes no sense. And if I had the square root of x, I can't divide by x and have the little square root sign sitting there, right? Same thing here. I can't divide by x and leave sign. Sign by itself doesn't mean anything. So I have to do the inverse. And the inverse of sine is sine inverse, or inverse sine, or also arc sine. But I don't think we really use that much in pre-cal still. It's inverse, sine inverse, or inverse sine. So we're going to rewrite this just so that we can make sure that we remember all this, because I don't think that you do this at all in algebra 2. So the sine of x equals 2/3. So whatever you do to one side, you have to do to the other. So I'm going to take the sine inverse of the sine of x and the sine inverse of 2/3. Well, what's the sine inverse of the sine of x? What does this give me right here? X. If you do something and then do the inverse, don't you just get what you started with, right? So that means here that x just equals the sine inverse of 2/3. And remember, you always take the sine, cosine, or tangent of an angle. What is in the fraction is always two side lengths, because that's what a trig ratio is a ratio of two sides of a triangle. All right, so I have this on here just because I want you to type in values and actually get them, so that if you're using a calculator at home that isn't exactly like this. Now remember, you can download this onto your tablet. If you haven't, I suggest that you do, even if you have your own, that way you don't have to carry it around. Right now, because we are doing angles and triangles like we are in degrees, so you got to make sure your calculator is in degree mode, right? So how do you get to that? Push the mode button, and then you arrow down to the third row and make sure it's on degree. Always check that. Okay, if you're using a calculator where you have to type things in backwards, and what I mean by that is the calculator that came with my phone. If I want to take the square root of 49, I don't do square root of 49 like I would on here. I do 49 and hit the square root button. So that's what I mean by backwards. The reason I want you to just have these values here that don't necessarily mean anything to you is because I want you to be able to double check that you're in the right mode and that you're typing it in the right order. Okay, so if you're not sure if your phone is in the right mode or something is in the right mode, if you do the tangent of 11 and you get anything other than what we get right here, then you're not in the right mode or you're not typing it in right. Okay, so go ahead on your calculator and just type those in. Get the tangent of 11. Sine of 62, cosine of 30. How many decimal places should we go to? 3, yes. So for tangent of 11, we get 0.194. Right? Sine of 62, 0.883. And cosine of 30. Now, should you know what cosine of 30 is without typing it in? See, in geometry, for cosine of 30, we would have used whatever was happening in the calculator, most likely. But you should know what the cosine of 30 is from your unit circle. What's the cosine of 30? Square root of 3 over 2. And you know what? Your only two options are 1/2 or square root of 3 over 2. It's clearly not 1/2, right? So square root of 3 over 2. So that's what you have right there. Now type in the square root of 3 over 2 on your calculator, see if that's what you get. Really, the exact values are what we're using now and not that. If you do not get that, you have to remember that the calculator is only as accurate and as intelligent as the person pushing the buttons. What do you have to make sure you do when you type in the square root of 3 over 2? Parentheses. It opens the parentheses for the square root, so you got to close it. And you should get the exact same thing you got as when you did the cosine of 30. Okay, we good on that? So remember to do the inverse. You have to do second tangent, second cosine, second sine to get the inverse. That gives you the angle measure. You're only doing the inverse when you're looking for an angle measure. Okay, so go ahead and just type those in, again, to make sure that you're getting the right values. I know that you're capable of pushing buttons, but I want you to have something to double check with when you are, if you're not sure if the device you're using is in the right form. Okay, so this should give you 36, and don't just write down mine, actually type them and make sure you're getting them. 8670, and that's degrees, right? Because this is giving me an angle measure and we're in degrees. And then this is 87.134 degrees. Oh, no, it's not. I'm sorry. Well, I was reading off of this. I forgot I changed them. Never mind. Y'all disagreed with me, right? Should have actually typed them in. Was that that wasn't the right thing, was it? No, I didn't think so. Sorry, I forgot I changed them from what I had written down. Tangent inverse of 3/5. There we go. 30.964. That make more sense? Okay. This one is still the same though, 87.134. And then what do you get for sine inverse of 2/3? 20, what is it? 810? Okay, there you go. So that way you have something without having to work a problem or whatever, you can just compare. If you can type this in and get this exact number, then you're in the right mode and things are getting typed in the right order in your calculator. Okay? Because I would really hate for you to do all the work and then you're not typing it in right and things are all bad. Okay, so let's solve some problems. So remember, right now we're going to find lengths, which means we're not doing inverse. We know what the angle is. Okay? The first thing you should do is label your triangle. Well, really the first thing you should do is either have in your head or right up at the top, SOHCAHTOA. You know whether or not you need to like actually write it down, but remember that when you write it down, if you don't spell it correctly, it doesn't do you any good. Okay? So I want to find each length. The length of ST right here. You can leave it as ST or you can put a variable here. I prefer putting a variable there so I don't do anything strange. And then I'm going to label my triangle. This is my angle. So this is the side that's opposite that. I'm not using that side. They didn't give me anything. I'm not looking for anything. This is what? What do I label this as? This is the hypotenuse, and then this is the adjacent side. So then which ratio uses adjacent and hypotenuse? Cosine, right? Adjacent and hypotenuse is cosine. So what do I take the cosine of? 42. So always have an angle. That's equal to the adjacent, which is x, over the hypotenuse, which is 9.5. You never, ever, 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 ever touch the calculator at this point. Okay? I don't care what the cosine of 42 is. Makes absolutely no difference. Makes absolutely no sense to type that in right here. You solve for x. What do you do to solve for x? Multiply both sides by 9.5, so you get x equals 9.5 times the cosine of 42. Okay? That is your exact answer. Then you can type that into the calculator if you are in the correct mode. And that should give you that x equals what? What do we get here? 7.060. Okay, that other 0 is important. That tells you that there's more stuff out there. What are our units here? Inches. Now we put x there. That's really the length of ST. Everybody good? Easy enough? Okay. All right, so the length of DF. All right, well the length of DF, let's label this differently. The length of DF is this, it's the hypotenuse, right? So if this is a capital E, then the side across from it is the lowercase e. That's where we can get that variable from instead of using a random x. So this is my angle. This, I label it as what? Opposite. I'm looking for this, which is the hypotenuse. This is across from the right angle. So what uses opposite and hypotenuse? Sine. So I'm going to take the sine of what? 51, because it's always of an angle, equals the opposite, which is 17, over the hypotenuse, which is e. So do I type in the sine of 51 on my calculator? Absolutely not. Do I multiply both sides by 17? No. Do I divide by 17? No. I can I can do those things. It's not going to get me anywhere. If I divide by 17, I'm not going to be left with e. I'll be left with 1 over e. But I really need to get e out of that denominator, right? How do I get e out of the denominator? Multiply by both sides. So I'm going to get e times the sine of 51 equals 17, then what do? Divide by the sine of 51, because that just represents a number. So E is equal to 17 divided by the sine of 51. Do you remember the shortcut we did here? What was it, Shelby? You just swap them. Do you notice how once we multiplied both sides by E, and then we divided by the sine of 51, these two just switch places? It's not magic, it's not a trick, it's not anything, it's just mathematically that's what's going to happen every single time. So if you have something that looks like this, and it's in the numerator, then you multiply both sides by this, you solve for x just like normal. You can go through these steps here, and there is absolutely nothing wrong with that, but the same thing will happen every time. So if the variable's in the denominator, these two values here just switch places, and it just makes it a little easier. All right, so then when we type it in, the length E is equal to what? 875, good. And that would be meters, and that is the length of DF. Everybody okay with that? We good? Is it all coming back to you now? Hopefully. You didn't do trig at all in Algebra 2, did you? No, I don't think you even talked about it. All right, so the length of BC, what variable would I put on this one? A, because it's across from A. So this is A. Right? And I am using this angle here. So this is which side? Opposite, right? Because it's right opposite that angle. What is this one? What do I label this as? Adjacent. If it helps you to label all three, in geometry I made you label all three at the beginning no matter what, because otherwise sometimes things are in the wrong spot. If you feel like you need to, so that you can make sure everything's in the right place, that's absolutely fine. Just make sure you understand which ones you're using, okay? So opposite and adjacent, which trig ratio is that? Tangent. So I'm going to take the tangent of 18. That's equal to what over what? 12 over A. So can I skip some steps here? What's my final result going to look like? Good. And remember, yes, you're using the calculator for this, but you still have to have this stuff written down. Okay? Your process still has to be here. I don't need or want to see the decimal for the tangent of 18, but I got to see this. And then when you put that in, you get that A is equal to 36 what? 932. And then there's feet on that, and that is the length of BC. Everybody okay with that? Okay, good. All right, so here, one more of these, and then we'll move on to the angles. So I'm looking for JL. What variable would I put on that? K. Lowercase k, but my lowercase and capitals look the same. And then that makes k the opposite side. What is this 13.6? Hypotenuse, good. What uses opposite and hypotenuse? Sine. So this is the sine of 27. That's equal to the opposite, which is k, over the hypotenuse, which is 13.6. Anything switch places? No, right? I don't switch places here. What do? Multiply. Good. So k is equal to 13.6 times the sine of 27. Then you can type that in. You should get what? Good. 6.174 centimeters. Now, let's talk about reasonableness of an answer just a little bit. Before you ever typed this in, because should you have kind of a concept of what the value of the sine of 27 is at this point? Yeah, because what's the sine of 30? Crickets. Come on, unit circle. What's the sine of 30? Square root of 3 over 2, right? That's the sine of 30? It's 1/2. The cosine of 30 is square root of 3 over 2. Okay, think about. So the sine is 1/2, right? So the sine of 27, close to 1/2, right? So about 1/2 of 13 is about 6 something, so you kind of got some reasonableness there. Plus, you know it has to be less than 13.6 because it's the hypotenuse, right? So make sure you're thinking about reasonableness here if you just get some weird stuff. Any questions at this point? All right. So this says find the unknown measures. So we got to find everything we don't know. I don't know the angle measures, and I don't know this side right here. What variable would I put on this side? B, right? Because it's across from the capital B. Oh, I see. Oh, wrong one. Okay, so we're going to start by finding angle A, right? So we're going to start with this angle. We're going to look for angle A first. So I'm going to label my triangle. The side lengths that I know, since I don't know the angle, I know this one, which is the opposite side. Which one is this one? Adjacent, right? So what uses opposite and adjacent? Tangent. Okay, so I'm going to take the tangent of what? A, and it's a capital A because it represents the angle. Tangent of A is equal to the opposite, which is 10, over the adjacent, which is 12. Do I need to reduce that? No. The calculator is about to take over, so you can, but I wouldn't suggest it because if you reduce wrong, you're just out of luck. Okay. So to get A by itself, what do I have to do? Inverse. So the measure of angle A is equal to the tangent inverse of 10 over 12. So what do we get for the measure of angle A? I'm going to redo second tangent. Good, 806 degrees. So there's the measure of angle A. Now, to get the measure of angle, I know angle B, I don't have to do that. Measure of angle C, can I do trig to find it? I can. Do I have to? No. What do the measure of angle A and the measure of angle C have to add to give me? 90. Okay, there's all three angles to add to give me 180, but the two acute angles have to add to give me 90. So I know that in order to find the measure of angle C, that the measure of angle C is equal to 90 minus the measure of angle A. Right? That's some process about where it's coming from. Like, I'm not actually typing that in. And remember, you never, ever, ever type a rounded or a truncated, any kind of decimal back in that you have found. So when we did this, and we did tangent inverse of 10 divided by 12, you got a couple of options. You can store it, but if all I'm doing is subtracting it from 90, I don't know that I necessarily need to do that. You can do a couple of different things. You can subtract backwards and get a negative number and know it's just not supposed to be negative. That's like the lazy way that I do, because I just know it's not supposed to be negative. But I can also do 90 minus, and I didn't store it, but I want that answer. So right here on the negative sign, second answer. So it's 90 minus the answer above it, and it gives me that right there. So I get 50.194. So now I know that the measure of angle C is equal to 50.194 degrees. Just learn how to manipulate the calculator to help you. Now I need to find the length of B. Can I use trig to find B? Yes, and if I do, I would want to store my answer. I'd want to store either angle A or angle C and store that, and then I can do that, but I'm not going to type the rounded one back in. What's another way I could find it? Pythagorean theorem. It is a right triangle with one missing side. I can totally do Pythagorean theorem. So now my missing side is technically my C in my Pythagorean theorem, but it's B here. Okay, that's going to happen, so you got to make sure that Pythagorean theorem isn't going to blow your mind or anything. So we get 12 squared plus 10 squared equals B squared. So 144 plus 100 equals B squared. So B squared equals 244. So you can use the calculator and get the decimal and whatnot, but you also need to know how to simplify your square root. Okay, B is the square root of 244. So even though you may not have to do it here, you do need to know how to simplify your square roots, so don't forget that. What do you get as a decimal here? Because I don't even know, because I didn't do it that way. 15.620? Y'all agree? Y'all got to talk louder. I'm old. I can't hear. Is that degrees? No. It's a lowercase letter. It's a side length. Okay. We good? All right. Awesome. Let's go ahead. I want to do this one too because I want to, even though I know you got the hang of it, but I still think I want to do this. We're going to start with angle B here. Okay. So angle B. This is lowercase b that I don't know. This is the hypotenuse. This is adjacent. So to find the measure of angle B, what uses adjacent and hypotenuse? Cosine. So the cosine of B is equal to the adjacent, which is 12 square root of 2, over the hypotenuse, which is 20. I could reduce it, but I don't care. Don't risk it. Measure of angle B is equal to cosine inverse of 12 square root of 2 over 20. So go ahead and type that in. What do you have to be careful of? Your parentheses. Otherwise, otherwise it tries to take the cosine inverse of 12 times the square root of 2 divided by 20, which is not what you want. And it's going to give you an error because a cosine value will never be greater than 1. So what do we get for the measure of angle B? .48 degrees. Good. Now, is finding angle C pretty easy? Yes, but we still need to write this down. Measure of angle C equals 90 minus the measure of angle B. Okay, and then you can handle that on your calculator however you see fit and whatever makes the most sense to you. Measure of angle C equals what? Good job, good job. All right, so now I got to find B, Pythagorean Theorem. So B squared plus 12 square root of 2 squared equals 20 squared. What is 12 square root of 2 squared? 288. And if you rely on the calculator for that, you are likely to get that wrong because, again, it's only as accurate and as intelligent as the person pushing the buttons. Did I even write it down correctly? What am I missing with what I wrote down? Parentheses around the whole thing. You square the 12 and get 144. You square the square root of 2 and get 2, so that gives you your 288. That's equal to 400. So that means that B squared equals what? What's 400 minus 288? 112. So B is the square root of 112. Let's simplify this one just for the heck of it because I feel like we don't always remember. And you're not always going to have a calculator. When you have to simplify them, you don't always have access to the calculator. So a number, don't even worry about what's the biggest number. This is even, so that could be 2 and what? 56? Is that even? Yep, so that could be 2 and what? And what? 28. Right, 2 and 28. And then 28 can be what? 2 and 14. And then 14 can be 2 and 7. And you may not need to go all the way down. Remember, one shortcut is to find the biggest perfect square that divides into there. And if you know what it is, that's great. If you have to take any time to think about it, don't bother. So that means that B is equal to what? 4 squared is 7. 4 squared is 16 times 7 gives you 112. Okay. Everybody okay with that? Any questions? right, so I have a couple of others down here. Why don't you just find the measure of these angles, angle T, while I pass out the homework. I'm not sure if I'll have time to do them, but. And that's all you have to find there. You don't have to find anything else. Should be simple at this point, hopefully. First one I get 35.496. Do you all agree with that? I already forgot. Crap. 35.496. You should write some stuff down too. I just don't want the bell to ring on me. So you need to set it up, but I want to make sure you get the right answers. 22.885. So this is what you should have gotten. Which trig ratio do you use on the first one? Tangent, and then on this one you use sine, which again should be written down, but I was trying to hurry so the bell wouldn't ring on me. Oh, there you go. All right. Have a great day. If you haven't downloaded the Wabbit Emu, I highly suggest you do that, because if you're having problems, I need to know. I don't have a fix for it yet, but I still need to know.